Find the safest path in a grid. We have given an 2D matrix grid of size n cross n. One cell of this grid can contain either a thief or it can be empty. Empty cell is represented by 0 and thief is represented by 1. Initially we have to start from 0, 0 and we need to return maximum safeness factor of a path leading to n-1, n-1. That will be last. From any given cells we can go either up, either right, either down, either left. Let's look at what is maximum safeness factor. So it's just a difference from a thief till our current cell. Let's look at example and try to understand this. So for example 1, given grid is this, we are standing over here and in this cell only we have a thief. So what distance we are from thief? It will be 0. Therefore the output is 0. Let's look at example 2. So for example 2, given thief is here and we are standing over here. What's the difference from this cell to thief cell? It is 1 and 2. So 2. Let's say if I move over here and I am standing over here, what will be my difference? It will be 1. So my safeness factor is, earlier it was 2, but because I moved right, I got 1. Let's say instead of going right, if we try to move down, now we will be standing over here. What will be my safeness factor? Thief will be from 1, 2, 3 or it will be from 1, 2, 3. So both the ways 3 will be my safeness factor. Now if I try to go over here, 4 will be my safeness factor. If I go over here, 1, 2, 3 or 1, 2, 3. 3 will be my safeness factor. And if I go over here, safeness factor is 1, 2. So it is 1, 2. So let's say if we follow this path, do you think our safeness factor is more from this path? Like minimum it was 2 and we need to return the minimum safest path and therefore it is 2. I hope you have got the example 2. Let's look at example 3. Initially we will be standing at here. So what is the safeness factor? It is 3 from here, 3 from here. Let's say our next step is over here or either we can move over here. What will be my safeness factor in both the case? It will be 2. Okay, cool. Now if I go over here, my safeness factor will reduce to 1. So I won't go over there and I won't be going over here as well because my safeness factor will be 1 again. Therefore the only way which I can take is this. Go over here. After this you can either go here or either go here. Let's say if you are going here, safeness factor remains 2. If you are going here, safeness factor remains 2. Then can you go here? Safeness factor will turn out to be 1. No, you can't go. So we won't go over here and we will go over here. Now minimum safeness factor is 2 till now. From here also it is 2. From here also it is 2. And at last 2 was the minimum. Therefore return 2. I hope you have got the question. Say our given grid as this. What intuition we can form over here is, let's say we are at this cell. Now somehow we need to find the distance between this and thief. That is 2. Now you can go over here and you can still calculate the distance. That will be 1. So for each possible step you will have to calculate this distance with the thief. But catch over here is that there could be multiple thieves. So you will require a lot of time complexity for this. But this should not be the case. So to reduce time complexity in this way, what we can do is like create our own array. Like initially mark the thief as 0. Over here it will be 0 and we don't have any thief. And do a BFS traversal and try to add the timestamps. If you are moving one block, just add 1. Like 0 plus 1 will be 1. So now you have moved like this. Now you will have to go over here, 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 here. Now from 1, now if you are at this block, you can move down. So it will be like 1 plus 1, that is 2. Over here also 2. Over here also 2. Now from 2 you can come down. From here you can come down. From here you can come down. From here you can go here. Something like that. So let's try to do that. You'll mark 3 over here, 3 over here. And now this part is left and it will be 4. Let's say you have created this matrix. Now will it be easy to find the distance between thief? Like you are standing over here. You are at 2 distance. Now if you go over here, you will be at 1 distance. So you are going closer. So don't go closer now. Go far. Go over here. So you are 3 distance apart. Then you can go over here, then you can go over here, then you can go over here, and this is our goal. But you might think in some cases here also thief could be there. So how you will be solving out this question is, you have to try all possible ways and just see the minimum distance. Like you are here, you want to go here, just use a Dijkstra's algorithm and see from where you can go to where. So creating this matrix is the simple part. Let's quickly try to look at the code part. Code will look something like this. We need to create this function, maximum safeness factor. So initially, like I have mentioned, create a safe grid for yourself. Let's see how we have created it. So this is a safe grid function. Initially I am trying to fill all the rows with -1 and now let's mark the thief. So just do a normal 2D array traversal, which is this. Just go to each block and just check if the block has thief in it or not. If it is, then mark the safe grid as 0 and add this in our queue, the coordinates in our queue. And then through our BFS traversal, just create our safe 2D array. Once you have created safe 2D array, now you just have to use Dijkstra's. So how Dijkstra will work over here is, let's say you have this array which we have created. I'll just rub this out. Dijkstra works on priority queue. So this is my priority queue. Initially, we will be storing our first value, that is this. So it will be like 0, 0 and the safeness factor is 2. This will be our max heap with regards to the safeness factor. Now just try to move in all directions. Like you can go to 1, you can go to 3. This will be removed and now you will be moving to another directions. Let's say you are moved in 1. So what will be its coordinates? It will be 0, 1. Then the safeness factor will be min of the original, that was 2, and the new, that is 1. So it will be like 1. And if you are at 3, what was the this? How max heap will look like is 1, 0, min of 2 and 3, which will be 2. Okay, so this is visited. Now this is also visited. This is also visited. As this is a max heap on the safeness factor, this will be at the top. Remove this, just rub this. Now from this you can go to here or you can go over here. Let's try to go to them. So first will be 2, 0. Min factor will be, safeness factor will be min of 4, 2. So that will be 2. And for this particular thing, it will be 1, 1. Min of 2, 2, that is 2. I'll just rub this out. Mark this as visited. Now as this is max heap, any of them can come up. Let's say this is coming up. Now you can go down or you can go right. Just add it in our max heap. So if we are adding 3, it will be like 2, 1, min of 3, 2, so it will be 2. Mark this as visited. Now we have to insert this. It will be like 1, 2, min of 1 and 2, so that will be 1. As this is max heap, this or this will be coming up. If you are going over here, this is already visited. You can see over here. So I'll just clear this out. Now this will be at our top of max heap, which is this number 2, 1. Now try to explore these paths like over here, over here, over here. But as this is visited, we will just go over here. So let's go to 2. Let's add 2. So it will be 2, 2, min of 2, 2, that will be 2. So added in our max heap. I'll just rub this out, mark it as visited. Now this will be at our top. Just check the coordinates of the top element. If x is equal to this one, the last element, that is n-1, and y is also equal to n-1, then just return this value, which will be 2, and which is our answer to question. I'll mention the code in the description below and on my GitHub as well. So do check it out and let me know if you have any doubts. Thank you.